Hi everyone, myself Dr. Lakshmi Prasad, working as a professor in the Department of Computer Science at Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about numerical methods. So, numerical methods. So, these are nothing but the algorithms that are going to be used to obtain a numerical solutions for the mathematical problem. And why do we need them? So, for this, no analytical solutions are going to be exist, and no analytical solution is difficult to obtain or practical here. So numerical methods means that these are algorithms that are going to be used to obtain a numerical solutions for a mathematical problem, and mainly for this, no sort of analytical solution exists, and it is difficult to obtain these analytical solutions or not practical here. So why do we need? What do we need here is that the basic needs in numerical methods is that practical. So that should be computed in a reasonable amount of time and accurate one. So that means that they do good and approximate to the true value, and then the information about the approximation errors is also good in this case. So what do we need? This means this should be the practical oriented one, and they should be computed in a reasonable amount of time, and it should also produce an accurate solution, so it should be could approximate to the true value, and then information about the approximation error also. So the outline of this video is that what should be Taylor theorem, and then number presentation, solution of nonlinear equation, interpolation, numerical integration, and solutions to nonlinear equation and linear square scarcity, and solution of ordinary differential equations, and solution of partial. So solution of nonlinear equation is that some equations are going to be solved analytically. So for this, this should be the quadratic equation we are going to have. So for this, what are the roots we are going to be identified for this case? Uh, so the roots would be minus d plus or minus b minus b plus or minus b square minus 4ac by 2a. So the analytical equation for this is that minus b plus or minus b square minus 4ac by 2a. So what is the b value here? That should be 4, and 4 is 1, and then b is 3. So 1 is square is 1, and c value is 3, 2 into 1. So the roots will be minus 1 and then minus 3. And some other equation also have that may not have any analytical solution. Let it be x power 9 2x square plus y equal to 0. So for this, x is equal to e power minus x. So what is the solution for this kind of equation? So nonlinear equations, right? So for this, what are the rules for this? So there should not be any analytical solution for this kind of problems. So what are the methods that are available for nonlinear equations is that bisection method, Newton-Raphson method, and then secant method. So these three methods are available for nonlinear equations. First one is the bisection, Newton-Raphson, and then secant. So what are the solution of systems of linear equations? So that should be x plus 1, x1 plus x2 equal to 3, and x1 plus 2 x2 equal to 5. So these are the two linear equations. So we are going to be solved 8. So x1 is equal to 3 minus x2, and 3 minus x2 plus x2 equal to 5. What to do if we are going to have 1000 equations in 1000 unknowns? So in this can how can able to solve? So if I'm going to calculate x1, so that should be we can able to send this value of x2 to the side. So value of x1 should be 3 minus x2. And what should be the value of x2 now? So how can I able to find it out? So for this, I'm going to substitute this equation in equation 2. Let it be equation 1, and this should be equation 2. So from this I got obtain x1 is equal to 3 minus x2. So I'm going to substitute here 3 minus x2 plus 2x2 equal to 5. Then 3 minus x2 is equal to 5. Then x2 equal to 2 here. So when x2 equal to 2, so finally what should be the x1 here? So 2 minus 3 minus 2, that should be 1. So this should be the value of x2 and this should be the value of x1. Okay. So what to do if we are going to have the 1000 equations in 1000 unknowns? How can you able to solve it? So for this, so Cramer's rule is not practical here. Now, normally these Cramer's rules are going to be used to solve the system, like we're going to have the two-fighter matrix like this. So, and then what should we do? Cramer's rule is more practical for large problems. So in order to solve this equation with n unknowns, so we need n plus 1 plus 1 and so on and so on, and practical multiplications. So what are the methods available for linear equations? Is that Gaussian elimination is one of the methods, and Gaussian elimination with the scale partial pivoting, and next one is the algorithm for tri-diagonal equations. These three are the methods that are available. So now Gaussian elimination and Gaussian elimination with scale partitional pivoting, and the third one is algorithm for tri-diagonal. What is the next one for curve fitting here? So given a set of data, so how can I able to construct it? Uh, so let us consider x and y value, x axis and y axis, and consider 0. So one is that 0 0.5 and another is that 10.3. So that is 1, 2, 3, and next one is that 20. So 20.3. So x is 1, 2, 3 here, and they should be 10 and they should be 20. So x is 0 0.5. Okay, and next what should be x value? That should be 1, 3. No, 1. For x value 1, it should be 10.3, and x value 2, it should be 20.2. So these are the values we have to be construct. So how can able to construct a curve? So once you mark all this, I can able to draw a line. So whether the points are obtained at the below this line or above this line, I have to find out. So select a curve that should be best with the data. So the choice is to find the curve so that the sum of the square of the error should be minimized here. And next one is interpolation. So interpolation means for a given set of data. So how can able to obtain this? So if I'm going to join it, let's straight in, so all the points are above. Suppose how can I able to obtain this interpolation? So we have a polynomial whose graph is going to pass the tabulated values. So then yi is equal to x of I. X of I is the value in the table here. So interpolation means for we have to find the polynomial x where the graph is going to process all the tabulated values and y is equal to p of x. So what are the methods that are obtained for curve fitting? So first one is linear square, least square method. So in this I'm going to show linear regression and non-linear regression. And next one is interpolation. So interpolation is another one. So here we're going to see Newton polynomial interpolation and then Lagrange interpolation. So these are other methods that are available for curve fitting values. So least square means here we can able to obtain a linear regression, and next one is non-linear least square problem. And for the interpolation, we're going to have methods like Newton polynomial interpolation and Lagrange interpolation. So integration means, so some functions are going to be integrated analytically. So for example, if I'm going to have the function like this, so x integration of x dx, so what should be the value for substituting this? So for this 1 by 2 x square, so we're able to take the values from 1 to 3 here. So if I'm going to substitute 3, so 3 square is how much? 2, and 2 is the value minus 1 by 2, that should be 1 by 4. So, but how many functions have no analytical solutions like this? So for this, if I'm going to have this equation like this, so what should be the analytical? So some of the functions is going to have uh, integration values, so that should be presented integral x dx. Suppose if I'm going to have the function like this, 1 by 2 x square, then how can I able to obtain this? So 3 minus, so integration of 3x square by 2 minus 1x square by 2, that should be 9 minus 1 by 2, that should be 4. So 8 by 2, that should be. So next problem is that, so how many integration functions we are going to have for that finding analytic. So for this we are going to have different types of methods like upper sum and lower sums, and trapezoid method, Romberg method, and then Gauss quadrature. So these are the methods that are available for numerical integration purpose. So mainly we are going to see about trapezoid and Simpson's rules by this. And next one, we are going to see what should be the solution for ordinary differential equations. So ordinary differential equation means, suppose if I want to have a differential equation like this, so what should be the solution for this ordinary differential equation? So if I'm going to have the function like s of t that is going to satisfy the solution, so the analytical solution that going to be avoided for this special cases only. So ordinary differential equation is something different. So we're able to obtain the solution that should be entirely different for that. And then next one, the solution for partial differential equations. So partial differential equations are more difficult to solve than the ordinary differential equation. Here I'm going to have the form of this partial differential equation like this. So dou square u by dou s square, and then dou square u by dou t square plus 2 equal to 0. And then dou mu of 0 comma t and mu of 1 comma t equals 0, and mu of x comma is equal to sine of by x. So these are the example of this partial differential equation. So for solving the problem. So summary is that, so numerical methods is nothing but the algorithm that is going to be obtained the numerical solution for the mathematical problem. So why do we need them is that no analytical solution is obtained. So that's why I'm going to consider this. And in this course, this video I covered some of the nonlinear equations, linear curve fitting, numerical integration, and the numerical differentiation solutions of these ordinary and partial differential equations. So that should be about in this video. So here I'm going to cover the numerical methods. What should be the main purpose of this numerical methods and all. So these algorithms are going to be used to obtain the numerical solutions to mathematical problems. So we're going to have different kinds of mathematical problems. So for this different kind of mathematical problems, we're going to have different kinds of algorithms. So mainly why do we need them is that no analytical solution exists for this kind of problem. So that too, this analytical solution is difficult to obtain and not practical. So the basic needs in the numerical methods is that we need a practical and accurate results. So practical means we can able to compute in a reasonable amount of time, and then accurately do good approximate to the true value, and then information about the approximation error. Then I'm going to see about some of the simple equations that is going to be solved analytically. Suppose if I'm going to have an equation like this, 3x square plus 9x minus 2 equal to 0. So how are we going to solve? So the roots of this equation is that minus b plus or minus square root of b square minus 4ac by 2a. So what should be minus b? Minus plus and then 81 minus 4 into 3 into minus 2 by 2a. So 2a is nothing but 2 into 3. So finally what I'm getting? So minus 9 plus or minus plus 24 plus square root of 1005 into 2 into 3. So that should be 6. Suppose if I'm going to like this 100, I'm getting square root of 100 is 10. So 1 plus or minus 1 by 6. So 1 to 2 should be 1 by 6 and the root should be minus 1 by 6. So like this we are going to be obtaining these equations or roots for this nonlinear equations. And some other equations also have like this x power 9 minus 2 xy plus 5 equal to 0 and then x is equal to e power minus x. So what about this analytical solution in this case? So for this no analytical solutions are available. And for this we are going to have some of the different methods like bisection method, Newton-Raphson method and then secant method. So what is this bisection, Newton-Raphson and secant? So some other solutions also going to have for linear equations. Suppose if I'm going to have the equations like this, so x1 plus x2 is equal to 3 and then how we're going to obtain the solution for this kind of linear equations. So if I'm going to have consider another example like x1 minus x2 is equal to 2 and x1 plus 2 3 x2 equal to 3 and x1 minus 2 x2 so 2 or how to consider 3. So what should be the values of x1 and x2? So x1 is equal to from equation 1 so 2 plus x2. So after substituting this in equation 2, so what will happen? So 2 plus x2 plus 3x2 equal to 3 and 2 plus 4x2 is equal to 3, 4x2 is equal to 1, 3 minus 2 and x2 is equal to 1 by. So by substituting this one, what should be the value of x now? So x1, so that should be 1 by 4 to LCM 8 plus 1 by 9 by 4. So x1 is 9 by 4. What about x2 now? So x2 equal to x1 minus 2. So 9 by 4 minus 2. So finally x1 is equal to 9 by 4 and x2 is equal to 1. So these and all will be the equations, values of x1, x2 for this kind of equations. And next one we are going to see about the Cramer's rule. So Cramer's rule can be used to kind of following type of system, but this will not be practically implemented for larger problems. And in order to solve this, and notes which should be also complicated. So for solving this non-linear equations, we are going to have Gaussian elimination and Gaussian elimination with scale partition, partial pivoting and algorithm for trigonal. And next one we're going to say about the curve fitting. So for the given set of data, how we're going to establish a graph like this. So for that, we're going to consider x-axis and then y-axis and taking the values of x1, so 0, 1, and 2, and taking the values of y, then identify and like construct a line that should be linked line, and some of the points may be able to lie below the curve and some point able to line above the line. So for this, what I'm going to say is that this should be this. So interpolation. So interpolation means here we are going to have x and y. So we're going to obtain like how to draw the curve like this. And what are the methods that are available for curve fitting is that, so least squares, and by the least square we're going to have linear regression and then non-linear least square problems. And for the interpolation we're going to have Newton polynomial interpolation and Lagrange interpolation. So the least square methods will be linear regression and non-linear least square problems in interpolation, Newton polynomial and Lagrange interpolation. So some of the functions also available in the form of integrals. So how can you able to solve this? So I'm going to have a function like this. So integral x cube. So how can I able to solve this from 1 to 2 to 4? So how can I able to establish this? So 4 cube by 4 minus 2 cube by 4. So that should be 64 minus 8 by 4. 56 by 4. So like this you can able to solve, but we're going to have some other function, then how can I able to do this? So for this also no analytical solution for this kind of integrals. So for this we're going to have some methods like upper and lower sum, strip join, Romberg method, and Gaussian product. So these are the methods that are available for numerical integration. And we're going to have ordinary differential equations also. How can I able to solve this? So the analytical solution for this kind of problem would be the special cases only. And solution of partial differential equations. So the partial differential equations will be looks like this. We are going to have dou square by dou square and dou square u by dou t square that plus 2 equal to 0. So thank you.
Like, share, and subscribe. Hit the bell icon for more updates.